Good day, everyone. I want us to quickly solve this problem. 20 cm cube of carbon 2 oxide is packed with 20 cm cube of oxygen. If all the volume of gases are measured at STP, which is standard temperature and pressure, calculate the volume of the residual gases after sparking. So what is going to be the volume of the residual gases after sparking? But this problem is under the Gay Lussac law of combining volume. And one thing that you need to know is that most times when you deal with this problem, when you deal with problems under Gay Lussac law of combining volumes, you have to write a chemical equation for the reacting substances. So meaning that for the reacting gases, so you have to write a chemical equation most times. So the first thing you need to do is to write a balanced chemical equation, not just an ordinary chemical equation, balanced. It has to be balanced. So what we are going to do now is that we're going to first of all write a balanced chemical equation for the reaction. Now remember, we have carbon 2 oxide packed with oxygen. So those are going to be the reactants that we're going to have. So I have carbon 2 oxide, which is CO, plus, well, this is a gas. So, and then I have oxygen. Remember, oxygen is a diatomic, hence the reason for the two I have there. Then CO plus oxygen is going to give us CO2. Now we have this chemical equation. Now we need to balance the chemical equation. Of course, I know that I have one carbon here, one carbon atom at this side. I have one carbon atom at this side, and I have one carbon atom at the product side. So that is balanced. But I have two. I have one hydrogen here, one oxygen here rather, and I still have two oxygen atoms here, making three. But what I have here is actually two. But what you're going to do is that now most times when you have odd number, so where you have the odd is what you're going to manipulate. So what I'm trying to say is that because of that, I'm going to add 2 here. I'm going to add 2 here. So if I add 2 here, meaning that this 2 is going to affect this carbon and it's going to affect this oxygen. So I have 2 atoms of oxygen plus 2 atoms of oxygen, making 4 atoms of oxygen. And now when you check the right hand side, you have 2 atoms of oxygen. So I can add 2 here. So, and that's going to be 4 atoms of oxygen. But notice that once you do that, then the number of atoms of carbon is no longer the same. So this 2 is going to affect carbon here, meaning that you have 2. And at the right hand side as well, this 2 is going to affect carbon, meaning you have 2. So the equation is balanced now. Now, according to, when you look at this problem, you have to understand, you have to realize that this problem is under Gay Lussac law of combining volumes, and there we deal with volumes. So what this equation is actually telling us is that 2 volumes from this balanced equation, you have 2 volumes of carbon 2 oxide reacting with 1 volume of oxygen to give 2 volumes of carbon 4 oxide. That is what this reaction, this equation is actually telling us. You understand that? Now, and now let me say this further. This is just like you're saying that for every 2 of these reacting with 1 of these, you have 2 of these. So now let's go back to the question. 20 cm cube of carbon 2 oxide are packed with 20 cm cube of oxygen. So before reaction, we have 20 cm cube of carbon 2 oxide, 20 cm cube of carbon 2 oxide. Now, also we have 20 cm cube of oxygen. I want you to understand that this is actually before reaction because we are not going to have the product yet. So we have this and this. 20 cm cube of carbon 2 oxide reacting with 20 cm cube of oxygen. Now, after reaction, what are we going to have after the reaction? So now we have to go back to our equation. So this equation says that for every 2 volume of these reacting with 1 volume, it has to react with 1 volume of these, and then we have 2 volume of the product. Now, what we are trying to say is that, let's say, for example, because a lot of people don't know how to go about this, or let me say a lot of students. Now, are you going to say that all these 20 is going to react? How do you know the volume of carbon 2 oxide that is going to react to the number of volume of what? Oxygen. Now, let's say we have this 20 cm cube here. So, and this equation, this balance equation, is to tell us the ratio they are trying to react. So we have this one, for every 2 of these, we have 1 of these. So meaning that if you say, let's assume, I'm not going to start from this carbon 2 oxide. Let's assume that I actually start from this oxygen. So if you say that the 20 cm cube of oxygen here reacts totally, and don't forget, this 20 cm cube of oxygen, according to the balance equation, is equivalent to 1 volume. So meaning that, and 1 volume of oxygen must always combine with 2 volumes of carbon 2 oxide, meaning that for every one of oxygen, we must have 2 times for carbon 2 oxide. So what I'm saying now is that if you say all the 20 of oxygen is reacting, definitely we must have 40 for carbon 2 oxide. But you look at it and say, oh, the number of the volume of carbon 2 oxide in the that we're trying to react is not up to 40. So that means this is not going to work. So I would rather start from here and say, oh, so this 20, the O20 here of carbon 2 oxide is reacting. So if the O20 is reacting, then you go back to the equation, the balance equation, and say, oh, I have for every 2 of carbon 2 oxide, I must have just 1 of what? Oxygen. So meaning that if this 20 is equivalent to 2, then what must be equivalent to 1 is 10. So, and that is what I'm going to say, oh, so meaning that the O20 of this carbon 2 oxide is going to react at the end of the day, 20 cm cube is going to react to form the carbon 4 oxide, but only 10 of this guy is going to react, of oxygen is going to react. Why did I say only 10? By now, I feel like you should understand, because for every 2 of carbon 2 oxide, you must just have just 1 of oxygen. So for the 20, if the 20 is the reacting here, then it is only 10 of oxygen that is going to react. And notice that we tried that for oxygen the other time, that, okay, let's say the whole 20 of oxygen is reacting. For every 1 of oxygen, we must have 2 of carbon 2 oxide. So if the O20 is reacting, that means we must have 40 for carbon 2 oxide. But the carbon 2 oxide in the container is not up to 40, so we cannot use that. And that's why we are using the fact that the 20 cm cube, all the 20 cm cube of carbon 2 oxide is equivalent to these 2. So, and since for every 2 of carbon 2 oxide, it is only 1 of oxygen. So if all these 20 of carbon 2 oxide is reacting, then only 10 of oxygen is going to react. So that is just the point to understand. So now, after you might have done that, then you look at the product side. You know, we also have 2 volume. So 2 volume of carbon 4 oxide must also be formed. And what volume is equivalent to this 2 volume? Well, it is 20, because we can see that 2 volume of carbon 2 oxide here is equivalent to this 20. And that is why this 1 volume of this must be 10. And 2 volume of this must also be 20. So that's what we are saying. So we are going to say the product form is actually going to be 20 cm cube. Well, we have actually done this, and that is why the equation is very important. The balance equation is very important here. Now, the question asks, the residual gases after sparking. Now, this is something you have to understand. After sparking this CO and oxygen in a particular container, remember that once this CO and O2 react, they will form CO2. So the volume of CO2 will remain in the container. Don't forget, the volume of the CO2 will remain in the container. So the CO2 is part of the residual gases in the container. Now, we also have another residual gas, a gas that the total volume did not react will also be in the container. Remember, we have 20 cm³ of oxygen, but only 10 of it is reacting with the CO, which is carbon 2 oxide. So, meaning that we are going to have the remaining 10 cm³ of oxygen in the container, and we are also going to have the 20 cm³ of the carbon 4 oxide that is formed as a product in the container. So the total volume of the residual gases is not going to give me, so total volume, so volume, I'm going to say volume of the residual gases volume of the residual is going to be equal to, well, I would have loved to write unreacted oxygen plus unreacted oxygen, so which is going to be, since only 10 reacted, so it's only 10 of oxygen that did not react, 10 cm³. So the volume of the residual gases is going to be unreacted oxygen. I'm not going to write that in words, so I'm just going to say, okay, the volume of the unreacted oxygen that is also going to be in the container is 10 cm³ plus, well, the other gas that will be in the container is the product that is formed. It will remain in the container. So we are going to have 20. And that is going to be the residual gases in the container. So cm³. Well, this is going to give us what? This is going to give us 30 cm³. Thank you.